The Earth Sciences Department at Dartmouth College has offered an off-campus field program known as The Stretch since the mid-1960s. The Stretch is a world-class opportunity for Dartmouth undergraduates to gain experience in traditional and emerging field techniques, all the while learning about the spectacular geology of Western North America. Their journey takes them from the Canadian Rockies to study glaciology, through our national parks, examining the environmental geochemistry of the natural soils and waters, and the geological structures and history of the landscape, and ending, quite rightly, in one of the 7 natural wonders of the world, the Grand Canyon. The 2013 Stretch took an unexpected and unprecedented turn because of 2 unrelated events. First, a catastrophic flood hit the Boulder, Colorado area, and then the national parks became a casualty of the federal government shutdown.
And so the national parks are closed, and that clearly impacts us. And I worry about that. I mean, for many of these kids, they've never been out west. This is the one chance that they're going to have, or they've had in their lifetime so far, to see the national parks. And to be sort of blocked at the entrance so they can't see them, it's definitely, it impacts them in a very negative way.
Well, one of the reasons I chose the Earth Science Department was because of this amazing program called The Stretch.
The Stretch is experiential learning. So they're just things you can't really do in the classroom. And there are problems you can talk about, but you don't really get a sense of what it's really all about until you can see them.
Upon arrival in Boulder, the Stretchies went right to work, helping with the cleanup for a family whose home was destroyed.
So there's lots of rock and then like woody debris that's thrown up on the banks and thrown through these people's houses and stuff. And so we're basically going to help them kind of clear that.
There were huge floods concentrated in the canyons around Boulder, and there was a lot of damage done.
My wife and I had to run through this mudslide right here. We left like 30 seconds too late.
And then it just kept raining and raining and raining and raining. It's all of my neighbors too, and just the whole community is what you're helping. It's really beautiful. And you all got some exercise.
It's more important that they get a chance to see how science actually works.
There was a pretty catastrophic flooding event a couple weeks ago, and we're here with Carl and some of the other hydrologist team to map it, and it's going to become a part of John's dissertation, hopefully, if the data works out for him.
Right now, we're doing experiential education. We are measuring real data in the field in a project that we devised this morning and are currently devising because that's how science works.
A lot of experience with like real field studies where nothing is pre-planned because it just happened.
We're applying a lot of what we've learned and coming up with our own conclusions.
The flood that recently came through here took sand and rocks away from some places and moved them to other places, and we're looking at where that erosion happened and where that deposition happened.
We've talked about some of the factors that increase sediment transport. What are they?
So we've been mapping where there's been erosion, where there's been deposition, and we should have a map of that for the whole length of the canyon now. So that's pretty fantastic.
It's like Carl was saying, it's like, what questions do we ask? What questions do we want to kind of explore about where things are going to be the most destructive?
So obvious erosion is something like a cut bank or a new stream channel.
Sediment movement. Okay, what we want to think about is, why does a particle move? I think it's, when we teach science in the classroom, we have sort of these prepackaged exercise, and we talk about inquiry and trying to lead them in things. But it's really not quite the same thing as going into a problem, into the field that you've never seen before, and coming up with what are the questions that we can actually answer, right? How can we actually make any sort of progress? And I've been sort of trying to emphasize to them that this is what it's really like.
We're creating a cross-section of the river. So by him reading off numbers on this rod when I'm standing in the river and knowing how high this is, we'll be able to create horizontal profile.
So they're getting a kind of a real-time view of how science works and how you come up with a hypothesis and how you can test that hypothesis and what data you need to test that hypothesis. So more specific to what they're doing is we're trying to figure out how this material got here. Was it just washed down by water, or was it washed down by a debris flow?
Is that what we should do?
That would be better. If you don't like your data, then you should improve it, right?
We are recording high water levels and original surface levels in order to find out how much sediment was deposited.
Try to find the base of the tree so we can measure how high the water originally was.
This is part of a larger project where we're trying to understand how streams work. Do they erode in some places for any real physical reason, or do they not? And can we add something to that scientific discussion?
That's what the stretch is, right? That's what fieldwork is like.
Carl is really cool. He's a really good teacher. He tends to teach with stories.
Carl has done a really good job working it out so that we can still do something relevant to each park nearby.
And it's a way for me to do science, which I love, being outside. And of course, this program is just a huge benefit.
Had like a chance to dip our feet into a bunch of different subjects, and now we're actually doing what the professors are doing with their lives, which is pretty cool.
So I think I'm doing earth sciences, A, because I do love the outdoors, and B, because I'm really interested in the stuff we're studying, how the earth works.
People, I think, generally do want to make the world a better place. And I think to do that, you have to understand how the world works. Or at least one way of making the world a better place is understanding how the world works. And ultimately, that's what we're interested in trying to figure out.